Welcome back everyone to another Kerbal Space Program video, and in today's Kerbal Space Program video we're going to be sending a satellite to Duna. This is actually kind of like a sequel video to the Duna colony rover, because if you don't remember, or if you didn't watch that video, that rover was actually stranded there because it didn't have any connection to the Kerbal Space Center, so we couldn't actually like drive it around or anything. But yeah, here we are in the vehicle assembly building the satellite. Nothing too special, just a fuel tank, an engine, a probe core, and then a satellite dish, some solar panels, and batteries. Yeah, like I said, nothing too crazy. Just needs to provide a satellite connection to the Kerbal Space Center. This is actually, I don't know, I really like building satellites. They're kind of interesting to build, and you can kind of go crazy with the designs, because you know, you could literally just send up a probe core and a satellite dish and some solar panels, and you know, you'd be set. But I really enjoy building like crazy satellites that are huge and completely unnecessary. But you know, Kerbal Space Program, yay. Anyway, there I was just putting on a reaction wheel, because I'm pretty sure probe cores don't include reaction wheels on like command modules, and you know, we probably need them since there's no RCS on this. But anyway, the satellite itself is done being constructed, and now we can start working on the construction of the rocket. There's that nuclear stage there, which is gonna get us into Duna's you know, sphere of influence. Nuclear engines are really good for interplanetary stages, because their thrust to weight is really low, but their fuel efficiency is really high. So you can, you know, you'll have a lot of delta V. You know, pretty standard rocket stage. The skipper engine, and then we have the mainsail engine. And here I'm placing these radially mounted liquid fuel engines, and these are set up in an asparagus stage. And the way an asparagus stage works is that you have 4 boosters, and 2 of them feed into the other 2, and those 2 that are being fed into feed into the main stage, so that they'll decouple at the same time as you're seeing here, and then by the time all 4 are detached, you'll have a full fuel tank in that main stage. So you know, it's way more efficient than just having like SRBs or not having them feed into it at all. But yeah, that's how far I'm willing to go on that tangent of radial mount rocket boosters. But there goes that main sail stage, and then now we're burning with the skipper engine to get us the rest of the way into orbit and raise our apoapsis to 80 kilometers, which we have just done. Now we can just plan our orbital insertion burn, which will get us into Kerbin's orbit. And there I'm just deploying those solar panels just to make sure that we have a good amount of electric charge. I'm pretty sure those batteries will last us all the way to Duna, because they're 400 electric charge in each, and that probe core doesn't really use much electricity while idle. I think the most use of electricity we use on this craft is from the reaction wheels. And you know, the keen-eyed among you might have noticed that you could have seen all the debris that was being toggled before, and that was then I went to the tracking station just to untoggle it, so you didn't have to see all the debris that we left in orbit. But you know, that might be a thing for a future video. Do some orbital cleanup, so we don't have a huge case of Kessler syndrome, where basically you just have a bunch of orbit stuck around like Kerbin or any other planets. But I digress. Here we are setting up our approach with Duna. You know, I like to have my encounter with the sphere of influence pretty high. So right here it's about 30 million meters, and then I will place a maneuver node later in interplanetary space so that we can do some more fine-tuning to our orbit to make it equatorial and to make it the correct height that we want. And here we are, just burning with that maneuver, just to get us to Duna. You can see our apoapsis is rising there, and you know, this is an example of how slow how little the thrust-to-weight ratio on the nuclear engine is. This is sped up in my video editor, and it's sped up in game, so it's sped up 4 times in game, and sped up 4 times in the video editor, so I'm pretty sure that's like a 16 times faster, and it took so long to do that burn. But you know, you can see that it was like a 1,000 meter per second burn, and you know, that's not even everything in our nuclear stage alone. But yeah, you can see that green line is our first periapsis, and then you know, I'm going to place another maneuver right now. Yep, there it is. And that's just, I'm just gonna use normal and anti-normal and prograde, retrograde, and radial in, radial out, all of the headings on the maneuver node maker, just to help our orbit be as perfect as we want it. Unless you're going, I mean, I don't think it really matters. It just depends on what you need to be in contact with, you know. And you'll see later in the video, I don't have contact with the KS yet sometimes from the rover, because the satellite is not directly over it. So if you need to communicate with something that's on the poles, you're going to need to get into a polar orbit, because the equatorial orbit won't encounter it. So that's just something to keep in mind as well. Just waiting here. There's always not much to talk about during interplanetary space, because there's not really much happening, just time warping to maneuver nodes and executing the maneuver nodes. But we got our trajectory down to the correct to the correct height above the surface, and we got it equatorial. So now we are just going to do our orbital burn, so we're just going to need to slow down. This is actually quite a long burn. It's like a 7-minute 25-second burn. That's pretty long just to deorbit, and the reason for that is because, number one, we're using the nuclear engine, which doesn't have much thrust to weight ratio, and then we're going to actually run out of fuel in that stage, so we're going to detach it, and then we're actually going to use that Terrier engine that I placed in there, which we're doing now, just to get us the rest of the way in orbit. And since we have such little thrust to weight ratio right now, what I'm going to do is I'm actually going to do multiple burns at periapsis to bring our apoapsis down lower in the in the correct altitude that we would like. So here I'm actually increasing our periapsis again, because since it took us so long to complete that burn, it wasn't as accurate. So it became about like 188 kilometers. I'm pretty sure it was 180 kilometers, and we were also getting an encounter with Ike, Duna's moon. So I had to fix that, and I actually had to change the direction of our orbit entirely. That way, we wouldn't get any gravity assists out of Duna's sphere of influence, as getting an Ike encounter would have resulted in. But yeah, there it goes. We just got our periapsis to the correct height, and there I'm planning the second burn at periapsis to bring us down into a circular equatorial orbit with a height of 200 kilometers. Same thing as always, fast forwarding to the maneuver node and then burning it when that maneuver node is half the time of the estimated burn time. There's a nice shot of Ike, Duna, and the satellite. And we're in orbit. So usually I would end the video here if this was just a normal satellite video, but the satellite has a purpose, which is to help us control the rover, which I'm doing now. I'm switching to the rover, and here it is. You can see that we're actually moving it, and there's that casing that I built for it when we sent it up. And the reason why I was flipping there is because I had SAS enabled, and when you have the SAS enabled, the reaction wheels are going to activate, and they're going to make the craft flip over and everything, and yeah. But if you notice, or if you did notice, before in the top left corner, you could see that little picture, or those little bars over there were actually empty, which means I had no connection. But when I time warped to make sure that our satellite's orbit was in correct alignment in relation to our rover, you can see they went fully green again. So we had connection. But that's the whole video. If you enjoyed, consider subscribing. Stay tuned for next week's video. And now our Duna base is kind of ready to start sending up modules and stuff. But yeah, see you in the next one. Bye.